Hello and welcome to the final video on the binomial expansion. This is the third lesson on chapter 8, so chapter 8.3 in the year 12 blue book. So we've done 2 lessons on the binomial expansion. This is going to just wrap it up with a few more examples and worked solutions. So let's have a look as ever at the warm-up. So 4 questions for you to have a go at here. 1, 2, 3, 4, here they are. So questions 1 and question 2 are going to help us with question 3 and question 4. So try these on your own. When you're ready to see the answers, press play, and then you'll see the answers I've got, so you can double check you've got them correct. So let's have a look now at question 1. So question 1, it says write down the first 4 terms of the expansion in ascending powers of b. So this is where the power of b gets higher. Now with a binomial expansion, the second term in the brackets is always the one where the powers increase, whereas the powers of the first thing, in this case a, they decrease. And so what's this going to be in terms of binomial expansion is, because we've got a power 10, we're going to start off with equaling 10 choose 0 of a to the power 10 b to the power 0. Now this is just going to be a to the power 10. The first term of the binomial expansion is just going to be this term here raised to the power that the brackets are raised to. So I don't need to write it like this, but I am doing just so you can see clearer than ever the pattern. So after that, what we're going to do is have 10 choose 1. Now a is going to reduce by 1 power, so down from 10 to 9, and b is going to up to power 1. Next along we have 10 choose 2, a to the power 8, b squared, and then finally it's going to be 10 choose 3, a to the power 7, b to the power 3. Now all we need to do is work out what these terms are going to be. Well, 10 choose 0, that's just going to be 1. How can you pick 0 items from 10 to choose from? Only one way, you just don't pick any. B to the power 0, anything to the power 0 is 1, so 1 multiplied by a to the power 10 multiplied by b to the power 0 is 1 times this times 1, so that just gives us a to the power 10. You can, of course, work these out yourselves using the calculator if in doubt. So to do 10 choose 0, we do 10, then shift divide sign, 10 choose 0, which you will see is 1. The next one we need to do is 10 choose 1. That's just going to give me 10. So then next along we're going to have 10 lots of a to the power 9 b, because b to the power 1 is obviously just b. Next, 10 choose 2. So go back, delete the 1, replace it with a 2. That gives us 45. So then we're going to have 45 a to the 8 b squared, and then 10 choose 3 is going to be 120, so we finish with 120 a to the 7 b to the power 3, and that concludes our answer. Those are the first 4 terms where the power of b is increasing, where b is ascending. Question 2, write down the first 3 terms, so not the first 4 but first 3 of this expansion, but now in ascending powers of a. So this is a bit of a trick question. We want the powers of a to be increasing, but if we were to do the expansion in this form, what would happen is the powers of a would be decreasing, would be descending. So what we can do as a little tweak to this is we can rewrite this, put the minus b first, and the plus a second. Now that little trick will make it run as we need. So then it's going to be 10 choose 0 minus b to the power 10 a to the 0 then plus 10 choose 1, minus b to the power 9, a to the power 1. Then finally, the third term in ascending powers of a is going to be 10 choose 2, minus b to the power 8, and a squared. Now, if we work out these coefficients, or if you remember what we got from question 1, 10 choose 0 is just going to be 1, so we're going to have just minus b to the power 10. But if we've got a minus term raised to a positive power, which is an even number, it's going to end up as a positive thing. For example, minus b squared comes out as positive b all squared. So minus b all to the power 10 is going to be just b to the power 10. The next one, we have a to the power 1, but this negative b is raised to an odd power because 9 is odd. So that's going to end up being negative overall. 10 choose 1 was 10, but because this is an odd power of a negative b, we can have minus 10 b to the 9a. However, we may as well do this alphabetically, as we always would do, and so we best write that as a b to the 9. And then here, we've got 10 choose 2, which is positive 45, because now we've got a even power of a negative b. So 10 choose 2 is 45, a squared, b to the power 8. And so we can underline this because that's our final answer now. Question 3. Use your answer to question 1 or otherwise to find in ascending powers of x, so x going bigger, up to the fourth term in the expansion 1 plus x to the power 10. So the big clue here is we can use the answer to question 1 to help us. So just to remind ourselves what we had from question 1, we had this here. And so now we can just say that a has to be 1 and b must be x, equating a and b to the terms in the actual brackets we need to expand here. And so if I do this and just colour code and highlight it, so we know that 1 has to relate to our a, so we get this. Likewise, our b, in this case, is now the x. So we can just make a simple substitution and use the previous result from question 1 of the warm-up to work this out. So if I just drop down here and say what 1 plus x must equal, to the power 10 no less, up to the fourth term, that's going to be a to the power 10, which is now 1 to the power 10, which will just be 1. Then we'll have 10 lots of 1 to the power 9. 10 times 1 to the power 9 is going to be 10, and b is x. So it's going to be 10 multiplied by x. Then 45 multiplied by 1 to the power 8. So 45 times 1 to the power 8 is just going to be 45. And b squared means x squared. And similarly, the last term will just give us 120 x cubed. And lastly, for question 4, using the answer to question 2, we need to find in descending powers of x, up to the third term involving x to the 8, this expression here, 1 minus x to the power 10, the first 3 terms of that. So it's worth remembering what we had from question 2, which was this. And so, of course, what I did here is we said that a minus b to the power 10, we said that was the same as minus b plus a to the power 10. Regardless, this is what we had as our result from what a minus b to the power 10 would be, up to the term in b to the power 8. So again, like question 3, for b here relates to the x in the brackets we actually want to expand. So just colour code this to remind ourselves that again it's exactly the same thing. Likewise, the a, yet again, is just going to be the constant 1. So if we plug these values in, where a equals 1 and b is x, we're going to get 1 minus x to the power 10. That's going to be b to the 10, which is x to the 10, minus 10 times 1 times x to the 9, so just minus 10x to the 9. Then here plus 45 multiplied by 1 squared, 45 times 1, which is just 45, b to the 8, which becomes x to the 8. And other terms will carry on, but because we only wanted up to the third term, this completes the question and in fact completes the warm-up. So we can now move on to the main bit of the lesson. We may, of course, be asked for just one particular term from an expansion of a bracket including 2 terms. So we might have a question where we don't actually need to work out the full expansion or the first 3, 4, 5 terms, whatever, but just one in particular term. And the good news is there is a way we can work this out, and there is a general pattern. So the general term in the expansion of a plus b to the power n is given by this expression here. And so if we want to, for example, to find the rth power of b, that would be n choose r, a to the power n minus r, b to the r. And so that will give you any general term you want. Now, this looks like a bit of a weird and awkward thing to remember, and the good news is you don't really have to remember this, because by using the pattern, you can generate this for yourself, essentially, which is what I'm going to show you now. So in this example I've got here, finding the individual coefficients using this, in this question here, let's imagine we want to find the coefficient involving x to the 5 in this expansion here. This is why, for one of many reasons, when I write out the binomial expansion for students, I include the first term as such. So what I'd always do is do the 8 choose 0 thing first, which some teachers don't do, and I totally get why not. So 8 choose 0, then we're going to have 3 to the power 8, and the 2x term is 0. Then what happens as you move along is we go up from choosing 0 to choosing 1, choosing 2, and so on, until you get to 8 choose 8 at the end. So the next one will be 8 choose 1. Now the power of 3 goes down by 1. The power of the last term of the brackets for 2x will increase by 1. So let's look at this here. We want the term involving x to the power 5. And so we want the term which is going to be 2x to the power 5. And so 2x to the power 0, 2x to the power 1. So if I just imagine blah 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 and start at the end, imagine we want 2x to the power 5. Well, the power sum will always be the same as the total power of a bracket, 8. For example, 8 is the same as 8 plus 0, which is the same as 7 plus 1. And so if this is a 5, we'll have 3 to the power 3 before it. Because in the same way, 3 plus 5 gives us this 8. So now all we need to do really is think about it's 8 choose what? Well, the final number at the bottom is going to always be the same power as what we're raising this final term to. So we had 2x to the 0, that was when we were choosing 0. 8 choose 1, we had 2x to the 1. If we're after the x5 term, then it'll be 8 choose 5. Using the idea that this thing here will always be the same as the power of the last thing in the brackets. And so the coefficient of x to the power 5 is going to be found by looking at this term. So using the quick way, we could have just used this here. We wanted our x term, which is this last one, which relates to the b here. So we were after power 5, and our n was 8. Because of power of a bracket, our n is 8. And so our r we were wanting was 5. So that was an 8, that was a 5. A to the power 8 minus 5, which is why this is a 3. Then this final thing, for 2x, which is our b, to the power 5. So this is the general term. I don't like this way. I personally can never really picture this. But what I'm trying to show you here is, by following on the pattern, you can always remind yourself of this general result anyway. So forgive me for just going down off a tangent there. So the x to the power 5 term is going to be found by looking at this. So all we need to do now is hone in and work out this coefficient. So 8 choose 5. Let's do this. 8 choose 5. That's going to be 56. Times 3 cubed. Well, 3 cubed is 27. And then 2 to the power 5 is 32. And again, you could work this out on your calculator. So the coefficient of x to the power 5 is this thing here. So if we just compute this, we've got it. So 56 times 27 times 32, it's going to be a big number. We're going to have 48,384. So we may as well just conclude by writing that in no uncertain terms. So therefore, coefficient of x to the power 5 is 48,384. Let's have a look at a new example now. So this one, find the coefficient of x cubed in the binomial expansion of 1 plus x in brackets 3 minus 2x to the power 6. So this one may well freak you out because it's not just one bracket, it's 2. But let's just expand this and see if we can spot the pattern. So I'm just going to start by writing out the question again, give myself enough space. So I'm going to leave this 1 plus x on its own and just think about the expansion of 3 minus 2x to the power 6. And so this thing here, because it's power 6, the first term is going to be 6 choose 0, 3 to the power 6 minus 2x to the power 0. Then we're going to have 6 choose 1. The power of 3 will decrease from 6 to 5. Meanwhile, the power of the minus 2x will increase to 1. Now bear in mind, this question, we only need to consider terms up to x cubed. So we're not even wanting anything beyond x cubed. We don't want x4, x5, x6. So the only thing we're interested in is x cubed here. So if there's a quick way of doing this, we could actually ignore this term here, because this is just going to be giving us something related to powers which are constants and just an x. So this actually isn't needed, but what I'm going to suggest we do to play it safe is just go all the way up to terms up to x cubed. So let's carry on the pattern. So next up we're going to have 6 choose 2, 3 to the power 4, minus 2x squared, and then we're going to have 6 choose 3, 3 cubed, minus 2x to the power 3. And it will continue, but I'm just going to go plus dot dot dot. So why would I not bother continuing? Well, let's just think about this. We only want to consider the coefficient of x cubed. So we're going to multiply this whole thing here, which is the 3 minus 2x to the power 6, which is this whole thing here. All this is going to be multiplied by the bracket which is coming before it, which you can see as this 1 plus x. But we don't care about anything apart from the x cubed terms. So after this term in x cubed, all the rest, these are going to be terms in x to the power 4 and higher, which we don't need to consider. Because if we multiply something where it's x to the power 4 by a 1 or an x, it's not going to give us anything in x cubed. So this bit here we're not bothered about at all. So that just doesn't matter. So what could we multiply 1 by to give us an x cubed term? Well, 1 multiplied by this will give us a term in x cubed. And so this multiplied by the 1 will give us a term in x cubed. In the same way, what could we multiply x by to give us a term in x cubed? Well, x multiplied by an x squared will give us something involving x cubed. And so essentially, if we multiply this thing here by the x, that will also give us a term involving x cubed. So now, just grouping these two together, we can consider what we'll have in terms of x cubed. So what we'll have is this thing here. So we'll have x multiplied by 6 choose 2, 3 to the power 4, minus 2x squared, by multiplying the x by this. And as well as that, we'll also have an x cubed term by taking this 1 and multiplying it by this here. So now we can just work out what we're going to have. And so here in the blue, the coefficient is going to be 6 choose 2. So 6 shift divide 2 multiplied by 3 to the power 4 multiplied by minus 2 all squared, which you could just put was 4, of course, because it is, but just to show you how you work it out the long way. So that gives us 4,860. So this will give us 4,860 x cubed. And in the red, we're going to have 1 multiplied by 6 choose 3 multiplied by 3 cubed multiplied by minus 2 to the power 3. And that's going to give us negative 4320. So actually not plus, but actually minus. Was it 4320? Yes, it was minus 4320 x cubed. So overall, that's going to give us 4860 minus 4320. That's going to give us 540 x cubed. In other words, the coefficient of x cubed is 540 in that expansion. Question 3. We have a function of x, which is defined as ax plus b, 1 minus 2x to the power 9, where a and b are constants. So we're told that given the first two terms of the expansion in ascending powers of x are minus 1 and 21x, we need to find the value of a and then find the value of b. So again, we're going to do this in a similar way to the previous example. We're going to leave the first bracket as it is and then just think about the expansion of 1 minus 2x to the power 9. And so here we're only concerned, by the way, with a constant term and the term in x. So we don't need to do the entire expansion, just terms up to and including x. And so f of x is going to be ax plus b multiplied by this. So just thinking of the expansion of this binomially. So the first term is going to be 9 choose 0, 1 to power 9 minus 2x to the power 0, then plus 9 choose 1, 1 to the power 8 minus 2x to the power 1, then plus other terms, which we don't need to consider at all, because these other terms here are going to be terms involving x squared and higher. So why don't we need to worry about those? It's because if you read the question, it says the first two terms in powers of x going up are minus 1 and 21x. So we don't care about anything x squared or higher. So now we can work out the value of a based on this. And so this is just essentially this bracket multiplied by these two terms here. So if I multiply the ax by this first thing here, minus 2x to the power 0, or anything to the power 0, it's just 1. 9 choose 0 is 1. And so this first term here is just simply 1. So ax multiplied by 1, that's going to equal ax. And this term here, 9 choose 1 is 9, 1 to the 8 is 1, minus 2 to the power 1 is just minus 2. So 9 times 1 times minus 2, this is minus 18x. And so this is going to give us ax. If we multiply that by minus 18x, we're going to have minus 18 ax squared. Then we multiply the b by what we had before. And so b times 1, that's just b. Then finally b multiplied by minus 18x, that's going to give us minus 18bx. And obviously the expansion will continue after, but we don't need to worry about that anymore. So we need to equate the constant terms to equal minus 1, and the x terms must have a coefficient rather of 21. And so now, let's just think about all the constant terms. Okay, well, ax involves an x. This is a term in x squared, so actually this one we don't need to worry about at all. This is a term in x. The only constant term here is actually just for positive b. And so positive b must be negative 1. So we worked out what b is. So therefore, we know that b equals -1, which I should put over here, of course. So I've answered part B first, weirdly, but never mind. An answer is good whether it comes first or last. We work something out, that's no bad thing. And so because b is 1, we can now work out what the other bits are. And so the terms involving the x's, we've got here and here. And so ax minus 18bx, in other words, the terms involving x, must equate to 21x. Only now we know what b is. And so ax is just ax, but because b is -1, this is -18 multiplied by -1 multiplied by x, which is the same as positive 18x, just subbing in b as -1. So if we subtract 18x on both sides, we see that ax equals 3x, then divide through by 3, we see that therefore a has to have a value equal to 3. And so ultimately for this question, a is 3 and b is -1. This now brings us to the last worked example. So question 4, we now need to think about this one here. So all we're told here is that p is greater than 0 and the binomial expansion of 1 minus 3x to the power p is identical to the expression below. And so what we need to do here is show that p equals 11. So let's work out what the binomial expansion would be in terms of p for this bracket. And so 1 minus 3x to the power p that's going to give us p choose 0, 1 to the p, minus 3x to the power 0. Now bear in mind, we only need to go up to terms in x squared, we don't need to do this whole thing. So the next term along would be p choose 1, 1 to the power of p minus 1, then minus 3x to the power 1. And the last term we need to consider is just p choose 2, 1 to the power p minus 2. I know and you know, this will just be 1, because 1 to the power of anything is just going to be 1. And the second term, the minus 3x, will now be power 2. And obviously the expansion will carry on based on whatever p happens to be, but because we only need to go up to x squared, we don't need to go any further than this. And so let's just now simplify this down. So first of all, a is just going to be the constant term, b is going to be inside this term somewhere, and the term in x squared, which is the only coefficient we're told, actually, is hidden within this one here. So I may as well just colour code this. And so a is going to come from within here. Bx is going to be from within this. And 495x squared is going to be hidden within this thing here. So we need to just think about this one I've highlighted in the light blue. Okay, so just picking on the blue, we can then say, therefore, p choose 2, 1 to the power, p minus 2, minus 3x squared, that must equal 495 x squared. So minus 3x all squared, that gives us 9x squared. 1 to the power whatever, that's just still going to be 1. So we have p choose 2 times 1 times 9x squared. That equals 495x squared. So what we have here, considering the coefficients of x squared, so this thing here must equal 495. So 9 lots of p choose 2, whatever p choose 2 is, must be the same as 495. If we divide through by 9, that just leaves us with whatever p choose 2 happens to be. So what's 495 divided by 9? Let's see. So 495 divided by 9, that's going to give us 55. So now showing that p is 11, well, we need to just use some trial and error really. We could use the factorial term, the factorial form rather, of what p choose 2 happens to be, and we can do that if we'd wish, but all we need to do really is just show what it might be. So 11 choose 2 is 55, so by substituting in p is 11, we show that it has to be 55. So we can just write that down. So we can just say therefore p equals 11 as 11 choose 2 equals 55. That's all we need to do, and that'll suffice. So by substituting in, essentially, that when p is 11, that gives the correct solution as needed. 11 choose 2 is 55, p choose 2 is 55, therefore p is 11. Part B. So we worked out that p is 11, we now need to work out the values of the a and the value of b. So we can now just go back and work out what we had from before. And so we had from before that 1 minus 3x to the power p is now 1 minus 3x to the power 11, by the way, because p is 11. We have minus 3x to the power 0 multiplied by 1 multiplied by 1 to the power p, so that's going to just be 1. This over here is going to be 11 choose 1, 1 to the power p minus 1, 11 minus 1 is 10, minus 3x to the 1, then plus 495 x squared, because we're told that the third term is 495x squared. So that's going to be 1. 11 choose 1 is going to be 11, but you can always use your calculator to verify that if ever you're unsure. So that's 11 choose 1, then multiplied by minus 3x gives us minus 33x next. So now we can just see by comparing what we've got. And so A, if you see here, A has to be 1. Likewise, B has to be minus 33. 495x squared is obviously 495x squared. So just by comparing these terms and coefficients, we can then clearly see that A has to be 1 and B has to be minus 33. Part C of this question. So we now need to use the expression to estimate the value of 0.97 to the power 11. So we've curtailed it to the first three terms, and so we're going to use these first three terms to estimate the value of 0.97 to the power 11. So just to remind us from what we had from part B, we worked out that 1 minus 3x to the p, where p we worked out was 11, using this curtailed, truncated expansion, it's roughly equal to a, which we worked out was 1, plus bx, where b was minus 33x, so where b was minus 33 rather, so 1 minus 33x plus 495 x squared. But obviously here we want it to be 0.97. Okay, so what we do now is we set 1 minus 3x, what we have in this bracket, equal to 0.97. So essentially we just give ourselves an easy equation to solve so we know what value to substitute into this to make it work. So if we arrange this equation, we'll clearly see that x equals 0.01. And that's what we're going to sub into the expansion. And so what we're going to get now is that 0.97 to the power 11 is going to be roughly 1 minus 33 lots of x, so 33 lots of 0.01, plus 495 multiplied by 0.01 squared. And so if we just bang this into our calculator and see what drops out, so we've got 1 minus 33 lots of 0.01 plus 495 multiplied by 0.01 all squared. And what we get coming out of this is this awkward looking fraction. Press S arrow D. It's 0.7195, our approximation. Now for D, we're going to see how accurate our answer actually was. So it says use your calculator to actually just work out what 0.97 to the 11 actually was, and calculate the percentage error in your answer to part C. So 0.97 to the power 11. Just type this in and write down all the numbers on your calculator. So 0.97 to the power 11. That gives us an answer of 0.715 301 4030. Sorry, 4031. So now this is going to return to GCSE. Can you remember the formula for percentage change, or in particular percentage error? The percentage error is always going to be the error divided by the original, or the actual in this case, actual value, multiplied by 100. And so the error is going to be the difference in between them. So 0.7195 was our estimate, minus away from that the real thing, which is 0.7153 ... blah blah blah. Divide that by the actual value, which again is this 0.7153 figure here. And all that multiplied by 100. So now you can use your calculator to help you do this without having to remember and key in all of these digits. Okay, we've worked out what 0.97 to the 11 was. This will be stored in your calculator's short-term memory. So if I just clear that by pressing AC, this will now be stored under the ANS button, as you can see. So now what we're going to do, use a fraction button, type in 0.7195 minus our stored answer, ANS, divided by ANS, multiply that by 100, and out will pop our percentage error. So to three significant figures, that's 0.587. That's not 58.7%, this is the percentage. So it's a less than 1% error, so it's very, very accurate, even considering just the first three terms of this expansion, which would actually have 12 terms in its entirety. And so the binomial expansion is a very powerful way of generating approximations to otherwise very hard calculations. So you can see here, by just taking the first three terms, we get a very good approximation to the real thing. Now, everybody, it's over to you as ever. So if you could try now these couple of exercises, well, these parts of these exercises anyhow, in your blue books. So page 166 and 167, exercise 8D, try these parts of question 1, then try question 2 through to question 10, then move on to exercise 80, question 7, question 8 and question 9. Keep plugging away, check your answers immediately, and ask me or one of your classmates for help if you are getting stuck. If you can't find me, come and see me during Achieve sessions or drop me an email. I'll get back to you as soon as I can. If I've not got back to you in a couple of days or so, that's rare, but do send me a nudge or a reminder and I'll get onto my emails straight away. Thanks again for listening. Good luck with these questions and tune in to the next video next time. Take care for now and goodbye.